Hi, I'm Doug Schmidt, and I'm going to talk about navigating the future of software engineering. In particular, I'll focus on how we can work together to assure the future of software engineering in the age of AI augmentation. We only have a short time together today, but there are many more videos on this topic at my YouTube channel. A PDF version of my presentation is available, so you can click on the links at the bottom of the slides and find out more information. Over 60 years ago, there was a famous Stanley Kubrick movie called Dr. Strangelove with Peter Sellers, and its tagline was "How I Learned to Stop Worrying and Love the Bomb." After working with generative AI extensively the past several years, I've revised this tagline to be "How I Stopped Worrying and Loved the Bot." About 5 years ago, I participated in a study at Carnegie Mellon University's Software Engineering Institute in conjunction with DARPA and the National Science Foundation. This study was charged with defining the national agenda for software engineering research and development. We interviewed many stakeholders and created a vision, strategy, and roadmap for engineering the next generation of software-reliant systems. When this study was published in November of 2021, it focused on 6 technology areas, 3 advanced development paradigms, and 3 advanced architectural paradigms. I won't cover all of them now, so please see the report for all the details. Our study looked 10 to 15 years ahead and aimed to be bold and visionary. One of the study's key findings was that the current practice of largely manual software development would be replaced by one where the software pipeline had humans and AI working together as trustworthy collaborators to rapidly evolve systems based on developer intent, rather than nitty-gritty coding details. At the time, we thought this vision was very far off. And then, of course, almost exactly 1 year later, in November of 2022, ChatGPT escaped from the lab. And unless you've been frozen in carbonite, like Han Solo, you know that ChatGPT and other large language models, or LLMs, can be used to synthesize new and original content in a conversational manner. After we recognized the power of ChatGPT and other LLMs, we conducted more research and thought more carefully about the 6 technology areas in our original study, 2 of which focused on AI augmentation for system operations and the software development lifecycle, or SDLC. Based on this experience, we've refined our original taxonomy to better explain AI's impact on software engineering. This slide shows the results of our work, which is a full-forward chart where the x-axis is the degree of AI augmentation in the SDLC from low to high, and the y-axis is the degree of AI augmentation for system operations from low to high. I'll start by describing the lower left-hand quadrant, which shows how over the past 70 or so years, programmers have largely used conventional SDLC techniques to build conventional systems that didn't use AI in their operation. A good example of these types of systems is the work I did on the ACE and DAO middleware, which are high-performance, object-oriented frameworks for developing portable, concurrent, and networked applications and services. ACE and DAO were applied to avionics mission computing systems developed with conventional SDLC techniques with no AI-augmented tools or methods. Likewise, there was no AI used in operating these systems, which is how the bulk of software-reliant systems have been built for decades. Over the past several years, however, conventional systems are increasingly being built using AI-augmented tools. For example, I've been teaching courses at Vanderbilt and elsewhere that demonstrate how to do this in the context of mobile cloud computing apps, such as web crawlers, where the logic and content of the apps and microservices are not AI-augmented, although the SDLC followed by my students applied AI-augmented code reviews, code generators, and testing tools. At the other end of the spectrum are systems that use AI, like YouTube, which uses AI to provide capabilities like recommendation engines, content moderation, and caption generation. Historically, however, that software was largely developed, tested, and deployed via conventional agile methods. And finally, we're rapidly moving towards systems with AI-augmented operations that are built using AI-augmented SDLC methods and tools. A relevant example of these systems is a self-driving car that uses machine learning algorithms for navigation and decision-making, as well as AI-augmented DevOps tools for software development, testing, and deployment. The SAI blog at the link below is a good place to keep abreast of advances in AI-augmented software development and operations. Of course, generative AI tools are not yet flawless, and are prone to hallucinations and other limitations with logic, truth, and grounded reasoning. We therefore need to adjust our expectations accordingly. For example, computer scientist Peter Denning wrote an article several years ago about his experiences with ChatGPT, where he said, "I noticed a certain style to the documents that ChatGPT generates. Most of what it tells you seems like you've already heard it somewhere. There are no radical departures from what others have already said. It also frequently outputs nonsense and speaks with great authority, even when outputting nonsense." When I read his article, I thought to myself, gee, that sounds a lot like me when I was a first-year computer science PhD student, because I didn't have a firm basis for my opinions at the time. Moreover, I spoke confidently, even when I didn't know what I was talking about. Fortunately, however, my professors, advisors, and fellow students worked with me to rapidly reshape my thinking and train me to be a better scholar. Of course, that's exactly what's happening with ChatGPT and other LLMs. They're improving rapidly. In the 2 years since Peter Denning wrote his article, generative AI tools have gotten substantially better, especially if you use them properly. In particular, to achieve success with generative AI and minimize hallucinations, we need to use the right versions and models for the right tasks. We also need to understand prompt engineering and prompt patterns. Most importantly, we need to think critically about the results we get from LLMs, learn how to separate sense from nonsense, and only trust the output from LLMs after verifying and double-checking it. Unfortunately, many critics and pundits dislike AI, so they don't follow its evolution closely and think that criticisms of AI from several years ago still apply. Nevertheless, for now, we're better off thinking about AI as augmented intelligence rather than artificial intelligence. We should use AI to supplement human intelligence rather than supplant it, akin to how the leader of the X-Men, Professor Xavier, uses a cerebro machine as an exoskeleton for his brain to see further and conduct analyses that normal humans can't do. What's also important in this phase of generative AI's maturity is understanding the consequences of making and detecting mistakes when deciding whether to apply LLMs to various tasks. My colleagues at the Software Engineering Institute published a paper 18 months ago that provides a framework for helping users determine where and how to deploy generative AI by asking 2 key questions. What happens if AI is wrong? And how easily will mistakes be noticed? The figure on this slide helps us think about where AI is safe and where it's risky. On the vertical y-axis, we have how bad the consequences are if the AI makes mistakes. On the horizontal x-axis, we have how easy it is to detect and fix these mistakes. The bottom left is the high-risk, hard-to-detect zone, where applying AI is problematic. Consider systems like medical devices, avionics controls, autonomous vehicles, or nuclear power plant control systems, where hallucinations or subtle logic errors from AI aren't just embarrassing, they could be catastrophic. In these domains, AI should not be used unsupervised. Now let's shift over to the top right, which is the low-risk, easy-to-detect zone. This zone is where generative AI shines on tasks like drafting emails, helping shop online, organizing schedules, or even building parts of a video game. If something goes wrong, it's obvious, and the consequences are minor, since you can just hit undo or try again. This diagram underscores the fact that we can't treat all AI use cases the same, since context matters, stakes matter, and human oversight matters. Now that we've given an overview of generative augmented intelligence, let's discuss the impact of augmenting the SDLC with AI. Generative AI can be applied to many, if not all, phases in the SDLC. We'll talk a bit about the different phases and which ones I believe are the most relevant shortly. I'll start out with an obvious high percentage prediction, like dunking in basketball, which is a high probability shot. Generative AI is having a transformational impact on the SDLC. A good example is the proliferation of AI coding assistants, which help improve the efficiency and quality of software development by reducing cognitive load on programmers. Many AI coding assistants are now available and becoming commonplace in practice. I've successfully applied some AI tools to my upper-level computer science courses for the past several years. I've had a delightful time, though they do make it harder to write assignments that can't be generated automatically with AI. OpenAI now claims to have an internal AI model that ranks as the 50th best competitive programmer in the world, though I'm not sure what their methodology is for substantiating that claim. They also claim by the end of the year, their model will be ranked number 1, whatever that means. Regardless of whether their AI model ranks 1, 50, or 1,000. The point is that AI-augmented coding assistants are improving rapidly. Moreover, AI-augmented tools in general are highly relevant for other roles and phases throughout the SDLC. We'll discuss their impact on activities throughout the SDLC in the next section of this talk. In the meantime, however, it's important to recognize that not everyone is as bullish as I am about the benefits of generative AI for the SDLC. For example, at roughly the same time as Peter Denning wrote about his disappointments with early versions of ChatGPT, Bertrand Meyer published an article with the provocative title that AI does not help programmers. Unfortunately, that title didn't age well, as shown by the tremendous progress in AI coding assistants over the past 2 years. While it's important to maintain measured skepticism, critics who think AI is not useful for software development miss the mark in several key ways. First, they often anchor their skepticism in narrow slices of the SDLC, typically zeroing in on problems with code generation or unit testing, without appreciating the broader and more nuanced demands of end-to-end software processes. This reductionistic view overlooks how AI can augment both earlier and later stages of the SDLC, such as requirements analysis, architectural modeling, traceability management, and long-term sustainment. While it's easy to critique AI for occasionally hallucinating code or missing edge cases in tests, these critics miss the forest for the trees by failing to account for how generative AI can accelerate stakeholder communication, translate informal user needs into formal specifications, or analyze sprawling legacy systems to support modernization. By focusing only on what AI can't yet do in isolated tasks, critics miss its transformative potential across the entire SDLC, where the real bottlenecks and human pain points reside. Likewise, critics often use AI tools incorrectly, or they use the wrong versions of these tools. For example, an article was published over a year ago that purported to show the limitations of ChatGPT for analyzing code to detect security vulnerabilities. However, it turns out they were using the free version of ChatGPT 3.5, which was much less accurate at code analysis than later versions. Critics also often fail to apply proper prompt patterns and prompt engineering techniques, which are structured ways of interacting with large language models to solve complex problems using natural language, as opposed to programming languages. Yet another problem is that critics often have unrealistic expectations about how long it takes to master the learning curve of AI. They think that if an LLM doesn't give them exactly what they want on their first prompt, that generative AI is useless and won't help programmers or software engineers. That defeatist view is like saying that if Michelangelo couldn't create the Pieta with 1 or 2 blows of his chisel, that he was a poor sculptor. Another concern people have is that the high-tech workforce will be decimated. This concern is not unfounded, especially in software development organizations, due to the rate at which AI technologies are improving. In the short term, my view is that AI is not yet mature enough to cause mass layoffs of programmers. However, programmers who know AI are in high demand, and they'll have a distinct advantage over those who don't use AI productively. Further down the road, we should consider the Jevons paradox, which predicts that AI's increased efficiency in developing software-reliant systems will ultimately yield greater need for skilled programmers due to the expanded growth in market demand. We've seen this paradox play out for decades, as assembly language programmers were replaced by Fortran, C, C++, Java, and Python programmers. Every step along the way, some people claimed the demand for programmers would shrink because systems engineers or even end users could generate software via high-level languages. Of course, as technology advances made it easier to create more powerful programs and apps, market demands for even more complex systems increased faster than our ability to provide a talented workforce to meet those needs. I think that trend will continue, though these expanded market demands may not happen overnight, and there will be challenges for entry-level programmers in the short term as companies explore whether AI technologies can make their existing workforce more productive without needing to hire junior developers. Moreover, developers building these systems, performing lifecycle management, requirements engineering, certification, and testing, will need to learn new skills. For example, they'll need to understand prompt engineering at scale. They must understand how to train and test large language models, and they'll need to learn how to deal with non-deterministic outcomes and outputs, which is especially hard in safety-critical domains where quality assessment teams are accustomed to a high degree of determinism and predictability. In this brave new world of AI, the best programmers and software engineers won't necessarily be the ones who can write code the fastest. Instead, they'll be the ones who can orchestrate software projects using many different tools and make them work together. AI orchestration tools connect AI models, tools, data sources, and services so they communicate and collaborate effectively and seamlessly. Orchestration is already essential in modern DevOps processes, but generative AI accelerates and accentuates this trend because these tools are so much more powerful than even superhuman programmers. The bottom line is that software professionals who have proficiency with generative AI will have a huge advantage over those who don't. I'd next like to talk about some of the challenges and opportunities we're facing with the AI-Augmented SDLC. Let's start by thinking more holistically about the SDLC. Much AI research to date has focused on downstream lifecycle phases, such as implementation and testing. Many published papers explore how to use LLMs to write code, sustain code, benchmark code, test code, and so on. In the domain of coding and testing, however, the measure of success is perfection. For example, if a compiler produced fast code but was only 95% correct, you'd likely avoid using it, since speed isn't worth the risk of subtle bugs. This success measure also largely holds true with AI tools that generate code, because if their output isn't perfect, that impedes correctness, reliability, and productivity. I therefore think software engineers should focus their attention on applying AI tools in other SDLC phases, such as defining requirements, visualizing software architecture, creating user stories and roadmaps, orchestrating deployment pipelines, and so on. Many artifacts throughout those phases are textual or based on diagrams, which are well suited for analysis and synthesis from AI tools, especially because the measure of success here is utility rather than perfection. In particular, AI tools for these other SDLC phases just need to outperform the current norm, which is costly and limited collaboration between teams of people. For example, the Software Engineering Institute has applied ChatGPT to analyze an Air Force manual that specifies safety design and evaluation criteria for nuclear weapon system software, where correctness and reliability are clearly very important. We use ChatGPT to detect document inconsistencies, incompleteness, and discrepancies, known as DID, in this manual. We found the manual contained inconsistencies and discrepancies, even though many smart people had worked on it for many years. We published some papers on DID detection, and it's a good example of applying large language models effectively to improve upstream activities in the SDLC. More generally, we're seeing better AI tooling throughout the SDLC via technologies like retrieval-augmented generation, or RAG, which matches user queries to predigested results that help LLMs generate more correct and responsive outputs. Likewise, AI platforms from OpenAI, Google, and Anthropic are integrating dozens of other AI tools and services that support many powerful programming and analysis capabilities. For example, quality assurance engineers in high-stakes domains like healthcare, finance, and national security can use LLM-based static analysis tools to check for compliance with policies and standards. The SAI has also used ChatGPT to check safety-critical code for compliance with specifications like the MISRA embedded coding standard and the CERT coding standards for C and C++, which are other examples of applying DID detection throughout the SDLC. Another opportunity for augmenting the SDLC with generative AI methods and tools involves formalizing prompt engineering as a discipline that centers on structured interactions with LLMs to solve complex problems using natural language and prompt patterns. This discipline focuses on problem solving and computational thinking rather than coding with conventional programming languages. As shown in a video in the link at the bottom of this slide, computational thinking in the future will be performed largely with generative AI tools and not programming languages like Java or Python. Prompt engineering is often a more appropriate means to perform computational thinking for non-computer science professionals, such as doctors, lawyers, and accountants. Within the implementation phase of the SDLC, prompt engineering has been integrated with modern interactive development environments, such as Windsurf from Codium or GNU Copilot. These AI-augmented IDEs enable developers to refactor and transform their code via prompting, as well as conventional programming. Another aspect of formalizing prompt engineering as a discipline involves codifying prompt patterns. Since the 1990s, programmers have been applying software patterns, which are reusable solutions to common problems that arise when developing software. They provide a template to solve a broad range of problems in various contexts. Likewise, prompt patterns codify best practices for phrasing prompts to maximize extraction accuracy from LLMs. While prompt patterns are useful, they focus largely on prompt engineering in the small. In other words, individuals problem solving more effectively and accurately with LLMs. However, where we're headed is not just viewing prompt engineering as a set of parlor tricks to get LLMs to do our bidding in isolation, but instead what I call prompt engineering in the large, or holistic prompt engineering, which involves building software-reliant systems via a combination of coding and prompting, as well as integrating quality attributes associated with software engineering, including configuration management, testing, compatibility across different versions and types of LLMs, prompt maintenance, and so on. The goal is to enable teams of humans and AI agents to build software-reliant systems with AI-augmented methods and tools that can be evolved and sustained for years without being buried under a mountain of technical debt. Prompt engineering in the large should be a priority for our research community, since it's not well understood yet. In particular, most people are just using prompt engineering in the small, and they won't be able to scale it up without more empirically grounded methods and tools. So let's go ahead and wrap up. Developing and applying generative AI effectively is a step towards achieving the future vision the Software Engineering Institute presented in the 2021 National Software Agenda Report, in which humans and AI work together as trustworthy collaborators. Although LLMs escaped from the lab 3 years ago and are rapidly disrupting software development and software engineering, achieving trustworthiness to the extent that humans no longer need to be in the loop may still be 10 to 15 years away. Ultimately, AI technologies need to mature to the point where we trust them to rapidly evolve robust software-reliant systems based on intent rather than handwritten algorithms and components. This approach shifts the focus to problem-solving and computational thinking rather than conventional programming, with all its accidental complexities like syntax and semantics, fence post errors, buffer overflows, concurrency, synchronization, and fault tolerance. Ideally, these advances will enable humans to focus on the more interesting and architectural aspects of software development and technology application, rather than wrestling with the low-level mundane coding details. I firmly believe that nearly everyone who uses an LLM should be viewed as some form of natural language programmer, rather than a programmer in the classic sense using Java, Python, C, or C++. We've written several widely cited papers on this topic that you might enjoy reading. While much research, development, and policy governance remains before we can achieve the vision of humans and AI working together as trusted collaborators, there's no time like the present to jump in and learn how to surf the AI wave. When you do jump in, please use the latest, greatest LLMs, ideally the paid versions, and use them wisely by applying prompt patterns and prompt engineering, both in the small and increasingly in the large as methods and tools mature. Generative AI is one of the biggest technology innovations in the past 2,400 years, eclipsing even the digital revolution in its disruptive impact on society and economy. We're living at a pivotal time, and it's exciting to help shape the future of technology and social evolution. However, we need to be sensitive to the forthcoming digital chasm between people who are AI savvy and those who aren't. We've long been worried about the digital divide, where some people have access to computers and the internet and some people don't. This issue is gradually being addressed. It's not perfect, but we're getting there. Unfortunately, the digital chasm is a much bigger problem. For example, some students coming to William & Mary are so far ahead of the professors with respect to AI proficiency that they're bored out of their minds, which is neither a healthy nor sustainable situation, since if we can't up our game rapidly, we're going to lose out. Of course, the digital chasm extends far beyond academia, so people who can't or won't understand how to use AI effectively and responsibly will struggle to compete in the workforce henceforth. The good news is that generative AI provides a unique opportunity to level the playing field, since very few people have more than several years of experience. Therefore, it's not hard to catch up if you're willing to devote time to mastering the tools, techniques, and methods of generative AI, which are getting easier to learn and apply at a dizzying pace by many online resources, such as the freely available massive open online courses on prompt engineering by Professor Jules White from Vanderbilt University. Moreover, recent studies show that people who are novices benefit more than experts from using AI, which is both wonderful and scary. It's wonderful when I want to learn a new skill and go from being a novice to being at least a pseudo-expert, since I can come up to speed very rapidly. However, it's scary when my students can do that as well, and I have to work hard to try to stay one step ahead of them in the classes that I teach. However, critical thinking and rigor are still required to avoid the brain rot that can occur when we outsource our creativity and higher order cognitive processing to AI. So we clearly have our work cut out for us as educators and researchers. Thanks again for listening to my presentation on navigating our AI-augmented future in software engineering. And please feel free to email me with any questions or comments on my talk.